Now here, in example 36, it says that Alex launched a ball into the air. And it says that the height of the ball can be represented by the equation. Okay, so we know one thing, and that is that the height of the ball can be represented by this equation. Just keep that in mind. Where h is the height, so let's underline that, and t is the time, blah blah, in seconds. After the ball was launched, let's graph the equation from t equals 0 to t equals to 5. All right, so now it says here that we need to graph the equation from t equals to 0 to t equals 5. So if it says graphing, well, let's use our graphing calculator. So let's turn it on. Let's clear this. Now, let's clear this. Notice that your equation, it uses the variable of t. So your equation has a variable of t, and it's asking you to graph the equation from t equals 0 to t equals 5. So we're going to just substitute it with an x. So let's put this same equation, but now in terms of x. So we're going to have negative 8 x to the second plus, we got that 40x, and we're going to add 5 now. All right. So we got here, we want to graph it from 0 to 5. So if we press graph, well, obviously it's not that clear, but always the easiest way for you to graph a function is to press second table and actually use the table values. So here we got plenty table values, but here we want from 0 to 5, so we don't want those negative numbers. We want from 0 all the way to 5. All right, so let's put our table values here. Let's just copy and paste those table values. So we have t and h. I think it's easier if I just use the tool here. So 1 second. So let's build our, oops, yuck, that's ugly. All right, so cool. So T of H, that's that, which again, in our calculator, that's X and Y, because that's how the calculator works. So let's choose a point. I mean, we went from 0 to 5, so we know that 0, Y is 5, so we got a point at 0, comma 5. We also have a point at 1 and 37. We also have a point at 2, comma 53. We also have a point at 3, comma 53. And we want to go all the way to 5. So we also have a point here at 4, comma 37. And lastly, we have 5, comma 5. All right, so let me just extend this. And again, this table values, we got them from, let me turn this on. We got them from here. So, okay, so notice that your axes are not labeled. So let's label them. What would be like a good grid? So let's say every 4 squares one unit. So 1, 2, 3, 1, 2, 3, 4. So let's say that here you have 1, 1, 2, 3, 4. So let's say you have 2, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. All right, perfect. So we went from 0 to 5. We have them. So now for the y-axis, I don't know. Let's just choose every 3 squares. It's 10. So 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And 1, 2, 3. All right, cool. Let's label those points. So we got 0, 5. So when x is 0, y is 5. It's, I don't know, somewhere around here. Let's get the next point. 1 comma 37. So at 1, we're going to go all the way up to 37, which is going to be somewhere around here. Then we have 2 53. So at 2, we're going to go all the way to 53. This is 50. Let's say 53 is right here. 3 and 53. So notice that here we have the same point, 353. And at 4, we got 37 again. So we got 4, we got 37, we got a rod right here. And at 5, we got 5. All right, so this is our graph. Let's just connect those points. Let me do the actual graph in black here. So okay, this just does not look good. All right, so that's our graph. Let me just make those points a little bit more noticeable here. So that was a coordinate point, that's a coordinate point, here, 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 and here. All right, perfect. So we have them there. So we already graphed it, so that's cool. So now, what they're asking us here, it says, so we have our graph, and that's cool. And it says here, state the coordinate of the vertex. Okay. And explain its meaning in the context of the problem. All right, so we have our graph here. All right, so we have our graph. So now we want to know, where is the vertex? So we got to remember what the vertex is. So the vertex is pretty much where the graph is changing directions. Now, what do I mean by that? Well, notice that here, if we go from left to right, this is saying, well, here the height is increasing, the height is increasing, the height is increasing. Then somewhere around here, the graph is going to start decreasing, decreasing, decreasing. And that point over here, that is changing directions, because notice it's going up, then it hits a point, and it starts going down. That point, it's called the vertex. And most of the time, it's either where your min or max is, either your highest or lowest value. So, I mean, you definitely don't want to take a guess. So we can ask the calculator to find the highest value for us. So if we come back to our graph, so we know that we have our graph here. Well, maybe this method is not that easy to look, but one way to see here is that, notice that, let's just use the table values here. So we established that it has to be a point somewhere around here. But the easiest way to identify the vertex, it's by looking at the whole graph is symmetric. Notice that it's here, you have 53 at 2 and 53 at 3. So that means that the vertex is going to be right here. So the vertex is in the middle. So the vertex is going to be at x comma 2.5. I'm sorry, x equals 2.5. Because notice here that the points repeat. At 2, you get 53. At 3, you get 53. So the vertex is exactly at the middle where those 2 points are repeating. So the vertex is going to happen when x is 2.5. So if we want to find the vertex, let me write this equation once more here. So we got our equation, and we want to know what happens when x is 2.5. So for the vertex, so we know that it's going to happen at x equals 2.5. So let's grab our function and let's just plug that in. So we're going to have h is equal to negative 8, 2.5. Let me put 2.5 in red so you know that we are substituting that. So we got 2.5 square plus 40. But instead of t, we're going to plug in 2.5 because we want to know what's going to happen at 2.5 plus 5. All right, cool. Let's plug this in the calculator and let's see what that gives me then. So let's clear that. So negative 8, parentheses 2.5, all to the second, plus 40, parentheses 25, plus 5. Perfect. Oops, my bad. So press enter here, and we got 55. So that means that the vertex happens when x is 2.5. Oops, no, this is 55. At 2.5, comma, 55. So this is our vertex. The vertex is right here. Now again, how do we determine what value of x we want to look at, or what value of t in this case we want to look at? Well, again, what happens here is that we look at our table values. Let me move this out of the way. We look at the table values, and we did notice that at 2 it was 53, at 3 it was 53. So the vertex needs to happen somewhere between those 2 points. So what the number that is between 2 and 3 is 2.5. So that's the number that we plug in here to find the vertex. So the vertex is a coordinate point, and when you plug it into the equation, you get 55. So that means that the vertex is at 2, 55. All right, so we already said what the vertex is. So now let's explain the meaning in the context of the problem. Well, let's actually see what the problem was about. This is saying there was a ball that was just launched. So they throw the ball up, and then here at 2.5, here at 2.5, at 2.5 comma 55, then that's the vertex. So note that you throw it up, and then at this point it starts going down. So in the context of the problem, what this means is that the ball reached a maximum. So the ball reached a maximum. A maximum what? The real reach a maximum height at 55 of 55, because notice that the y value, that's the height. So the ball reached a maximum height of 55 feet. Hold on, is this being given in feet? Well, it doesn't say. It just says that it's a height. Well, let's just say that it's feet. So 55. Let's not even just say that the height of 55 after 2.5. After 2.5 seconds, the ball was launched. Cool. So let's see if it makes sense. I mean, they throw the ball, and at this point, the height is 55, and it took them 2.5 seconds to reach this point. So once it reaches this point, then it starts going down. So if at this point it starts going down, then that means that the highest value or the maximum height will occur at this point. So that's the meaning of the vertex in example 36 here. So now, lastly, example 35. So it says here, Ian is borrowing 1,000 from his parents to buy a notebook computer, and he plans to pay them back at the rate of $60 per month. And Ken is borrowing 600 from his parents to purchase a snowboard, and he plans to pay his parents back at the rate of $20 a month. We want to do is we want to write an equation that can be used to determine after how many months the boys will own the same amount. All right. So what this suggests is that we need to create two equations. We need to create one equation for Ian, and we also need to create one equation for Ken. All right, so let's look at each of them. It says here for Ian, he is borrowing 1,000 from his parents and to buy a notebook. So he borrows 1,000, and then he plans to pay them back $60 per month. So what is the cost, or how much is Ian going to be owning per month? Well, he borrows $1,000, and every month he's going to be paying back $60. So that means that the cost, or how much Ian is going to own, is going to be 1,000, which is what he originally borrowed, and every month he's going to take away $50 from that amount. So let's say if this makes sense. Well, when he borrowed, he owned 1,000. So the first month passes by and he pays 60. So now after 1 month, is going to be 1,000 minus the 60 that he already paid back. So that's 940. Another month passes, so he pays another 60. So that's 880. Another month passes and he pays another 60. So this is an equation for Ian. So now let's look at the scenario for Ken. It says here, Ken is borrowing 600 from his parents to purchase a snowboard, and he plans to pay his parents back at a rate of $20 per month. So now for Ken, how much is Ken going to be owning every month? Well, for Ken, he's going to be owning 600, which he borrowed at the beginning, and every month he's going to be paying $20. So it says here, let's write an equation that can be used to determine after how many months the boys will own the same amount of money. All right. So if we want to know when are they going to be owning the same amount, so we know that this is how much Ian is going to be owning. Oh, we know that this is how much Ken is going to own. So if we want to know when they're going to own the same amount of money, well, let's just put those equations equal to each other. So they will own the same amount when the two equations are equal to each other, which is pretty much saying 1,000 minus 60m equals 600 minus 20m. Perfect. Now, if we read here, it says determine algebraically and state in how many months the two boys will own the same amount. All right. So we already have an equation for it. This is the equation to see when they're going to be owning the same. So let's just write it out again. Now, it says here that we need to determine and state in how many months will the two boys own the same amount of money. So what this means that from this equation, we're going to solve for n. So in this equation, we're going to solve for m. So let's do that here real quick. Again, let's just solve for n. I see that the easiest way to go about it is to subtract 600 here. Take it out, so that's 400 here. Minus 60m, minus 20m. All right, perfect. Let's keep solving for m. What can we do? Well, let's add 60 here. That cancels out, so now we have 400. Minus 20 plus 60, so that is 40. To solve for m, we gotta divide it by 40 now. Cool. So now this is saying that m is equal to 10. So this means that after 10 months, Ian and Ken will own the same amount of money. Okay, so we got one more thing to say here. It said Ian claims that he will have his loan paid off 6 months after he and Ken own the same amount. Determine instead if Ian is correct. All right, so we know that he and Ken will own the same amount in 10 months. So they will own the same amount. Oops, that's just one M. At 10 months. So if he's saying that he will have his loan paid off 6 months after he and Ken will owe the same amount of money. So here we want to see what happens at 16 months. Because Ian is saying that he will have his loan paid off 6 months after he and Ken owe the same amount of money. So we know that they own the same at 10. He wants to see what happens after 6. So that's 16 months in total. Cool. So let's use the equation that we found for Ian. So I of m equals, this is the equation that we found for him. So 1000 minus 60m. We want to know what happens at 16 months. So let's plug in m for 16. That's 1000 minus 60, and let's plug the 16 there. You do this correctly, this says that em at 16 months, that is equal to, if let's do this in the calculator real quick here, let's clear it out. So 1000 minus 60 parentheses 16, so that's 40 bucks. So this is saying that after 16 months, Ian will still owe $40. So was he right? Nope, he was not right. So let's just say in here, Ian is wrong. At 16 months, he will own $40. All right, this concludes our review for the Algebra 1 Regents for January 2017. Hopefully this was helpful.